Here's a fully rewritten version of your script, keeping it engaging and mysterious while removing headings and hashtags. For centuries, humanity has sought to understand the universe, but often, the more we learn, the more questions arise. In the dark expanse of deep space, something has been discovered that challenges everything we thought we knew. It is strange, elusive, and unlike anything observed before. Hidden among the earliest structures formed after the Big Bang, a new class of objects has emerged, too small to be galaxies, too powerful to be stars, and far too red to fit into any known category. These objects remained invisible to all previous telescopes until the James Webb Space Telescope arrived. With its unparalleled infrared vision, the impossible has become visible. Astronomers have begun referring to them as little red dots, but their true nature remains a mystery. Some suggest they might represent a missing link between the first galaxies and supermassive black holes, while others suspect something far more bizarre: remnants of a cosmic era governed by rules we no longer understand. The story of these enigmatic objects is a reminder that the universe has always held secrets beyond our imagination. The journey began decades ago, when radio astronomers in the 1950s first detected a peculiar object known as 3C273. It looked like a star but emitted energy across a spectrum that no ordinary star could produce. Its chemical signatures were unlike anything previously catalogued, and its emissions flickered unpredictably. These objects were eventually called quasi-stellar objects, or quasars, almost stars, but not quite. Compact yet brilliant, smaller than our solar system but visible across billions of light years, quasars challenged astronomers to rethink the cosmos. Eventually, their nature was revealed: supermassive black holes surrounded by violent accretion disks. It took over 20 years for science to unravel that puzzle. Now, the James Webb Telescope has uncovered hundreds of new anomalies, echoing the mystery of those early quasars but breaking nearly every rule we thought applied. Smaller, dimmer, and cloaked in thick dust, these objects are only visible in infrared light. They seem familiar yet entirely alien. Initially spotted by Japan's Subaru telescope, these faint blobs were named Shelkas, short for Subaru High-Z exploration of low-luminosity quasars. Their luminosity was far too high for their size, and their deep red glow couldn't be explained by distance alone. James Webb's infrared eyes revealed something astonishing: these objects weren't just dusty, they were suffocated by it. Entire galaxies wrapped in thick molecular clouds, hiding their inner workings. Within, gases moved at velocities far beyond anything possible in ordinary stellar systems, suggesting the influence of supermassive black holes. Yet these black holes were unlike any seen before. Their host galaxies were too small, their light signatures unfamiliar, their jets and accretion disks hidden beneath cosmic fog. These were not faint quasars, they were something entirely new. Perhaps primitive structures that existed only in the chaotic youth of the universe, disappearing long before the formation of modern galaxies. As more data emerged, patterns began to appear. The Shelkas shared traits with the mysterious little red dots captured in Webb's early deep field images. Compact, luminous, dust-enshrouded, and observable only in infrared, they seemed to exist in a narrow window of cosmic history. Roughly 600 million to 1.5 billion years after the Big Bang. Before and after this period, they vanish. What could live for such a brief epoch and then disappear entirely? Spectral analysis revealed further mysteries. These were not traditional galaxies or simple quasars. They were active galactic nuclei of a new kind, black holes growing too rapidly within unusually small systems, immersed in extreme environments. Some scientists speculate that these red dots could be the embryonic forms of modern quasars, or perhaps a failed evolutionary path for black hole formation. Others propose a more unsettling idea. They may represent remnants from an era when the universe operated under different physical rules, echoes from a time we no longer comprehend. Even more puzzling, many of these objects emit no X-rays, despite showing the hallmarks of black hole activity. The explanation may be chilling. The dust surrounding them is so dense that it traps the most energetic radiation, allowing only faint infrared emissions to escape. If true, this suggests entire populations of early supermassive black holes have been hidden from view, not by distance, but by the very fabric of matter around them. This challenges our understanding of cosmic history, revealing a universe more crowded with massive black holes than previously estimated. The anomalies don't stop there. Some of these objects display precise, periodic fluctuations in brightness, seemingly linked not to dust rotation or stellar activity, but to a deeper, gravitational rhythm. These pulses may be matter spiraling into a black hole at exact intervals, or perhaps echoes from an earlier stage of universal evolution, reverberating across spacetime. This behavior hints at phenomena that could reshape our understanding of gravity and cosmic mechanics. In the end, these discoveries remind us of how little we truly know. The universe was once wilder, stranger, and more violent than we could have imagined. Its earliest chapters were not written in ink, but in fire and gravity, in chaos and collapse. Black holes did not form slowly, galaxies did not emerge gradually, and the laws of physics may not have been as immutable as we assumed.